Welcome to Wabash Alloys, North America's largest producer of recycled aluminum. Every year throughout our 6 plants located in the United States and Canada, we recycle over 1 billion pounds of aluminum. Wabash Alloys receives many different types of scrap at many different recovery percentages. Recovering the most usable metal from the scrap is what our business is all about. How much we recover depends in many ways on how well we follow proper procedures. In the next few minutes, you will see how scrap is received, graded, sampled, processed, sorted into bins, charged, poured into the final product, and then shipped to our customers. You will learn the proper way to flux or dross and skim the furnace. You will also learn the process of hot cleaning. It all begins when the scrap arrives at our receiving docks, where the scrap must be graded properly. Part of the grading process is called sampling. All scrap which is received is checked for complete analysis. A fire assay is a good example of sampling, where borings, turnings, spinnings are checked for moisture, fines, and free iron to determine the expected recovery percentage. All scrap which is received is checked for complete analysis and recovery. Processing is an important part of our business. Its purpose is to prepare scrap for the furnace and maximize recoveries by removing burnables and free iron, paint, grease, rubber, dirt, and oxides. Drying, shredding, sweating, and rotary furnace are the most common processing techniques. Once the scrap has been processed, it is now moved into furnace-ready bins, where it is segregated by analysis and anticipated recovery rates. Once the scrap has been received and processed, it is now ready for charging, fluxing, and drossing. This stage is extremely important because it affects the actual recoveries from the scrap. What we want to emphasize here is that our objective is to leave all or as much metal units as possible in the furnaces. Drossing. This can be accomplished by proper charging and drossing procedures. For example, if Wabash Alloys throughout our 6 plants recycles 80 million pounds of scrap in a month and recovers just 0.5% better than expected, that adds up to a gain of 400,000 pounds of extra recovered metal we can sell, just by doing our jobs right. Now that we know how important charging and drossing is, take a look at this next segment and identify everything that's wrong with what you are seeing. How many of the following 10 mistakes did you notice? Number 1, the oxidation and burning of scrap because it was left too long in the charger without being worked down. 2, no flux was added. 3, the operator did not wait for the bucket to heat up so that the holes would be open. Mistake 4, this dross was very dry. 5, see how long it takes for the aluminum to drain. 6, notice how the operator failed to drain aluminum. Mistake 7, aluminum burning, which causes aluminum loss. 8, the aluminum does not separate due to lack of flux. 9, the amount of aluminum in it. 10, the aluminum is still burning after it was skimmed, and because it is still burning, it can no longer be recovered. Now that we have seen the wrong way, let's watch the whole operation again. Only this time, notice how each procedure was done properly. Notice the metal temperature, the charge being added, flux being added, scrap being worked in immediately, the bucket is being preheated and has open holes. See how quickly the aluminum drains because separation has already taken place. The lack of burning and smoke. Finally, the difference in dross. One was burning, one was little beads of dross. Dross is black with good metal separation, which means that the aluminum content in the dross can be recovered at the hammer mill. Did you notice that the big difference between the right way and the wrong way comes down to 2 things? Working the scrap immediately and adding the flux. Don't forget, it's just as easy to do it right as it is to do it wrong. Hot cleaning. Now that we've talked about scrap recovery, proper fluxing and drossing procedures, another issue that affects furnace operations and efficiencies is hot cleaning. Hot cleaning is a procedure that we perform to clean the inside of a furnace while the furnace is in operation. Some plants use different tools and techniques, but the reasons why we do it remain the same. 1, to maintain furnace capacity, and 2, to maintain furnace efficiency. Furnace capacity simply means that we can maximize pounds out per heat poured per day from the furnace. When the term furnace efficiency is used, the first thing that should come to mind is BTUs. BTUs is a unit of measuring the quantity of energy being used to perform work. In our case, BTUs is expressed as BTUs per pound, and it simply means how many BTUs are used to melt 1 pound of aluminum. How are BTUs affected in everyday operation of our furnaces? Let us assume that the normal BTUs per pound is 3,000 when the furnace is clean or new. As the furnace is used, buildup on the wall and the metal surface inside the furnace would increase the consumption of BTUs per pound. Example, 1 inch of buildup would increase BTUs by 27%. 2 inches of buildup would increase BTUs by 38%. So you can see that with more buildup, we use more BTUs to melt 1 pound of metal. Since we have to buy gas to generate BTUs, buildup ends up costing all of us more money. In addition to buildup, there are other conditions that will use up more BTUs. 1. Furnace pressure. 2. Improper sealing of furnace doors. 3. Failure to keep the inside of your furnace clean. Pump maintenance. Furnace efficiency can be increased by using pumps to circulate the hot metal from inside the furnace to the charge well, resulting in a faster melt rate. The faster we melt, the faster we can produce a pour or heat. A quick way to make sure that pumps are running at peak is to look at the charge well when it is at peak. If the flow is not running at peak, then check the pump. Notice how the pumps are cleaned off and the difference cleaning makes. We are in an intense, highly competitive industry. Survival comes down to how well we all do our jobs. If we maximize scrap recoveries through proper charging and drossing procedures and maintaining our furnaces at top efficiency, we will keep and build on our position as the low-cost producer of secondary aluminum alloys in North America. In return, we'll have the competitive advantage we need to operate our plants at full capacity and to secure our jobs, not only for today, but well into the future.